Good morning. My name is John Mayo. I'm a professor of economics, business, and public policy here at Georgetown University, and I'm also the executive director of the Georgetown Center for Business and Public Policy, which is our host for today. Let me welcome all of you to what is now our 6th annual Forum on Technology and Policy. This year, we are going to drill down a bit and focus on issues of 5G and its role in healthcare and manufacturing. We're very excited about this. To do that, we're going to have 2 panels of experts. I'm very excited about having both panels. The first panel will be moderated by Peter Rosavi, who is the president of Rosavi Associates, and we'll focus on technology, on the technology side of 5G and what it might enable. The second panel will be moderated by Carolyn Brandon, who is a Senior Industry and Innovation Fellow at Georgetown, and will focus a bit more on the role that policy might play in enabling and complementing 5G and economic welfare, what the possible accelerants are and what the possible impediments are to economic growth in that space enabled by 5G. So we're really excited about both those panels. To kick it off today, we're also very excited to have Brendan Carr, Commissioner at the Federal Communications Commission, who is himself an expert on both of these issues, having studied spectrum and driven the spectrum and innovation process at the FCC and looking at what factors might enable economic growth from a policy side on 5G. And so we're really excited about having him offer some keynote remarks. I think he's agreed to, after having offered these remarks, answering a few questions. So get your questions ready as you go. I will simply say also, and this is maybe the most important thing I could say, is that he's also a Georgetown graduate and a distinguished alum, and he's enhancing the reputation of the university, both through his public service and in a variety of other ways. So please help me welcome Commissioner Carr.
John, thanks so much for that introduction. It's great to be back at my alma mater. I went to undergrad at Georgetown, graduated in 2001, and then went on to law school from there, so it's great to get a chance to be back and give some remarks here. And today's event and the topic is exceptionally timely. Facilitating this transition to 5G is one of my top policy priorities at the FCC. And 2 of the reasons why we're so excited about this transition to 5G is what we're talking about today, which is how it can impact manufacturing and healthcare in the country. And starting out on the healthcare side, I've been commissioner at the agency for just about a year now. In that year, I've spent a lot of time outside of DC, and I visited about a dozen manufacturing plants to see everything from high-tech to traditional low-tech, and see about the broadband and connectivity needs of those facilities. In fact, my very first trip as a commissioner at the end of last summer was to a small town called Claremont, North Carolina. And it's home to a fiber manufacturing plant. And they had indicated that they are increasingly busy giving this push to 5G. Because after all, 5G is about, as we'll talk, thousands, hundreds of thousands of new small cells being deployed, but we also need many, many miles of fiber and other wired connections to link this new network. Most recently, I took a look at some of the manufacturing plants in Minnesota and North Dakota. We were at a 3M facility in Minnesota, and then in North Dakota, we visited a plant that's producing essentially steel containers and conveyor belts for the energy industry. And the person that's running that plant, Micah, walked us around the shop floor. He said that without broadband, without a high-speed connection, that plant wouldn't be located in this small town in North Dakota. This plant has 800 jobs. It's probably the largest employer in the county. And they simply would not think that's one example of where we're going in the manufacturing space. How do we keep plants open? How do we attract plants? How do we have jobs? Well, broadband's a piece of that. And 5G is increasingly critical. The Wall Street Journal has looked at this transition from 4G to 5G. They said that it is going to be transformative from a not just technological perspective, but an economic perspective as well. The country that wins this global race to 5G is going to be positioned for an economic leadership role for the next decade. Here's how we know that. You think back 10 years ago, the last time that we were in the midst of a transition in technology from 3G to 4G on the wireless side. You think back to the biggest companies in the U.S., the largest drivers of our economy, biggest stocks. They were big banks and big oil. Fast forward 10 years, now it's technology companies that are some of the biggest drivers of our economy. There's a reason for that. In that intervening time, the U.S. won the race to 4G. Whether it's Apple or Amazon, Google, or the latest small startup, a lot of this is riding on our world-leading 4G network. Our app economy, for instance, has transformed so much of what we do. You think about your own life, exchanging money 10 years ago, required going to a brick and mortar bank, standing in one of those rope lines, you go to fill out a check, you had to pull one of those pens that was leashed to the table and was always out of ink every single time. You had to go and talk to a teller and conduct your transaction in person. Now we have apps, whether it's Venmo or other apps, that transform that banking experience. Or think about how you get across town. Pick up the phone, call a taxi cab company, you have to wait 20 minutes. Think about all the rides that it wasn't worth the hassle or the cost. Now, you pick up your smartphone, whether it's Uber, Lyft, Via, you have convenience right in your hands. Now, it's difficult to predict everything that this shift to 5G is going to enable. After all, if you look back again in the early 2000s, people were trying to think, what are we going to do with all this new high-speed broadband? What is going to be the killer app? The most that a lot of people could see at that point was VoIP, Voice over Internet Protocol. VoIP was saw as the killer app for broadband. And now you think about all of the new cutting-edge innovations that we couldn't even have thought about. That's sort of where we're positioned right now. And you think about winning this race to 5G, we're not the only country in the world that wants to do that. China, for instance, is looking at this transition to 5G as a chance to flip the script. They want to be the technology and innovation hub in the next decade. They saw what leadership in 4G meant for U.S.-based technology companies. And they have a plan, and it's an infrastructure plan. Since 2015, for instance, they've deployed about 350,000 cell sites. And these are essentially the building blocks for 5G. Over that same time period in the U.S., we deployed 30,000 cell sites. Right now, China is building cell sites at a pace of 460 new sites a day. That's 12 times the pace that we've been working in the U.S. So whether it's manufacturing or healthcare, how do we get 5G deployed? We have to win this infrastructure race. One of the hurdles, one of the reasons why there was this growing gap on the infrastructure side between the U.S. and China is our regulatory structures. Now, some of that is pretty fundamental. We have a very different approach than China in a lot of ways. But we have rules in place that were unnecessarily holding back and slowing down the private sector in the U.S. I'll give you two examples. One, we have federal historic and environmental review procedures that apply to the cell sites. And for 5G, we are transitioning into a space where upwards of 80% of all new deployments are going to be small cells. These are backpack size, pizza box size antennas. They're very, very different than the 200-foot towers that mark the 3G and 4G deployments in the past. These can go on utility poles, light poles, existing infrastructure. But we need hundreds of thousands of more small cells. The problem was our federal rules assume that every new cell site is a 200-foot tower. They require costly reviews, lengthy reviews, that may have made sense for a new 200-foot tower given its impact. It didn't make any sense for putting a new shoebox size antenna on an existing pole. So in March, we issued an order that excluded small cells entirely from those federal review procedures. There's an economic study that showed it was expected to cut about $1.6 billion in red tape. One provider has reported that since that decision, they're now starting to clear small cells for construction at 6 times the pace of before. Another provider just reported yesterday that in the last 6 months, they built more small cells than they built in the prior 2-year time period. So we're making progress in closing that infrastructure gap. We also saw that there were challenges at the state and local level. A lot of state and local zoning and permitting process, just like the federal regime, have been assuming that these new small cells are no different than a 200-foot tower. Again, costly, expensive permitting processes. As we traveled around the country in this job, we met with state leaders, local officials, particularly in rural communities. At the end of the day, if we don't update our approach to regulations, the biggest cities in the country, they're probably going to get 5G and next-gen deployments no matter what. New York and San Francisco are going to see new small cells almost regardless of what we do. But we met with leaders in dozens of other communities that are outside of these big must-serve cities. And they told us that they were worried that the high costs required to deploy small cells in these big must-serve cities was sucking up the capital needed to make sure that 5G and next-gen connectivity would reach their community. They understood, whether it's healthcare, manufacturing, or just the economy generally, what getting this transition does means to them. So we listened to their concerns, we followed their leadership, and just last month we issued another decision in the Commission that put some basic common sense guardrails in place with that local permitting process. Made sure that cities are fully compensated for their reviews of these new deployments. No locality should be going underwater with the private sector's deployment. But we put some guardrails in place to make sure there's not going to be excessive fees which can prevent small cells from going in across the country. We put some new shot clocks in place as well to make sure there's a timely action. And the economic studies there show that that's going to cut another $2 billion in red tape. It's going to incentivize like $2.4 billion in new investment, 97% of which is going to be in rural and suburban communities. And that's the goal for us. How do we make sure that every single community gets a fair shot at next-gen connectivity? We started out a little bit on the manufacturing side, but I'll tell you why it's so important on the healthcare side as well. We were in Mississippi Delta a couple months ago, a small town called Louisville, Mississippi. It's one of the poorest corners of the country, and it's a place that sees diabetes at about twice the national average. We've got a woman there named Miss Annie. She first noticed the signs of diabetes when she woke up one morning with blurred vision. And she tried going through traditional care approaches and wasn't seeing much progress. But in Louisville, there was a small clinic, Sunflower Medical Clinic, that was trialing a new approach. What they did was they sent Miss Annie home with an iPad and an app and a Bluetooth-enabled blood glucose monitor. And we met with her, she walked us through it, and she was able to get through all the apps and all the technology pretty easily. And what she would do is she would prick her finger every morning, and that would send the A1C level right to her iPad. And based on that number, the iPad would analyze it and say, you eat this today, don't eat this, do this exercise, don't do this activity. And she saw a dramatic reduction in her A1C level. And we were talking to her, she said that she never felt better. And with that one pilot program, we took it statewide in Mississippi, and just 20% of the state's diabetes population enrolled, it would save the state about $189 million in Medicaid expenses. And that's great, but we need to upgrade our network to 5G to really take that at scale. There's a limit right now in terms of how many devices, IoT type devices, healthcare devices, the 4G network can sustain. But if you move to 5G over a 1 kilometer space can carry about 2 billion devices. So if we want to take the experience of missanding, we got to upgrade to 5G. If we want to make sure that every single community gets that same fair shot that we saw in the Mississippi Delta, we have to drive down the regulatory costs to make sure that every single community in the country benefits from 5G. And so that's really what our focus is on the commission. And again, I think manufacturing and healthcare are going to be two of the most important sectors that can benefit from 5G. So happy to take some questions that you all have on that, either 5G manufacturing, the healthcare side, or anything else you'd like.
We have those that walk around the room with microphones, and raise their hands, and we would ask for you to identify yourself and your affiliation, so I'll go ahead and be the person. And we're just going to start up here and then work our way down, okay? There you go.
Thank you very much. My name is Rajendra Singh, and I'm working with the World Bank here in Washington, D.C. Thank you for excellent presentation. My question is, and great you have done this facilitation of 5G deployment. What about the millimeter wave spectrum? Because, as you mentioned, that more than 80% are small cell sites. The distance is very short. So why to kind of regulate millimeter wave spectrum? Let it be free, because the propagation distance will be very, very less, and operators can manage it themselves. Thank you.
Yeah, thanks. I'll say a couple things. It's a good question. So when you think about 5G, a lot of the focus early on is on small cells, which, as you point out, are going to operate on millimeter wave spectrum, very high band spectrum. Ultimately, though, we're pushing 5G technology down through all of the spectrum bands, whether it's going to be mid-band, for instance, we have 3.5 gigahertz, which needs some commission, or all the way down to a sub-1 gigahertz spectrum. Ultimately, we're going to be transitioning when we have 5G technologies operating across all spectrum bands. Your point about small cells on millimeter wave, the spectrum, as you point out, doesn't travel this far, so that's why you need the dense deployment of small cells. We're working in terms of the licensing and unlicensing approach to make sure we have the right mix. We've got unlicensed millimeter wave spectrum coming, licensed coming, and we also have sort of novel hybrid approaches that we're incorporating as well. And one reason why we're going to update our regulations, particularly for small cells, is we need so many more of them. So we've got to find a way to bring the regulatory costs out of the system, and that's going to flip the business case for thousands of communities where it may not have made business sense to go into hundreds of small cells. So if we cut the regulatory costs in half, which is essentially what we've done with our last two decisions, a lot more communities that are going to see small cells than on West Road.
Name is Dave Oswald, no affiliation. I'm sorry, I know that the commerce of the future has been increasingly conducted, online and that kind of thing, the stores that, that don't have cashiers and that kind of thing. The question I have is, will there be ways to do this, business, these stores, without requiring mobile device costs hundreds of dollars and data plan costs some hundreds of dollars a year, which is sort of what it is now. And I'm trying to get, will the technology make it cheaper to do business online for those who do not want to pay for the, expensive mobile device and the data plans? This is my questions.
Yeah, I'm going to take one piece of that, which is the devices themselves. And part of your question is about how do we drive down the cost of these consumer devices, which may be key to doing business going forward, as your question pointed out. Well, that's one of the benefits that we're looking at with 5G is as well. When you move to this low latency network, you can take a lot of the intelligence off of the device and put it on the edge of the network. So one benefit we're looking to see is that the devices can become cheaper, and you're moving, again, the intelligence off the device and into the network. So I think that's one benefit of 5G in terms of driving down the cost of these consumer devices.
Into the data plans.
Yeah, again, we're increasingly seeing data cost per megabyte of data driving down. As we're adding massive new capacity with high band spectrum, we expect that trend to continue as well.
Hi, my name is Annie. I work for Senator Johnson, and I've recently had a few meetings with groups who are really concerned with 5G, with the dense deployment of the small cells, and either concerned on potential harmful effects, or they want local communities to have the right to not have 5G. And so I would love to hear how you respond to these concerns, so I can better respond to them as well.
Sure, yeah, there's a couple pieces of that. One piece of the question, I think, is about the RF emissions from these devices. And this has been an issue that some owners have been raising for decades, going back to the 3G and 4G era. And the FCC, along with health and safety agencies across the government, are constantly keeping abreast of the latest science, and there's rules in place, emission limits, that everything has to comply with, designed to ensure the safety of these devices. The second piece of it is, goes to continued local control. This was something that we were sensitive to. I mentioned we issued a decision in September that put some guardrails in place on the local process. Well, one thing that we heard loud and clear when we were going through communities, Fishers, Indiana, for instance, was the importance of aesthetics in the local review process. And so we specifically recognize that state and local governments can continue to regulate the deployment of cell sites based on reasonable and objective aesthetic considerations. And at the end of the day, if an ugly small cell goes up, someone's not going to call or email me, it'll be their local officials. We wanted to make sure that local officials can continue to regulate based on reasonable and objective aesthetic considerations.
All right, any other questions? Howard? One more from the back, and then I think we'll transition to one question.
I'm Matthew Hine with the Department of Commerce, and I want to touch on the China point. China is not the only country out there. Korea perhaps is another. There could be a 5G avatar that everybody follows. What recommendation would you give to try to help facilitate U.S. companies who may have the 5G technology who want to sell their products abroad and have a more an easier time trying to get those pizza box sized, small sized devices from a regulatory perspective, and also awareness that this is the route that 5G is going to go? How do we make the case that the U.S. has the leadership role, and we're going to be able to leverage it from that manufacturing perspective as well? Thanks.
Yeah, some of these manufacturing plants that I visited, I mentioned some are not necessarily telecom equipment, but I have been to Samsung and Ericsson's 5G manufacturing facilities in a number of cities in Texas, for instance. And from my perspective, the FCC, we're obviously not trade experts, but what we can do is act within our authority. What we have been seeing was this increasing infrastructure gap starting in 2015, and we need to create a runway to let U.S.-based companies, whether they're manufacturers or providers themselves, compete on what's approaching a much more level You can ask any question you want, I will answer.
Indicate you wanted me to ask you questions, so I'm just trying to how are Western Communications data? After the order was approved, the recent major infrastructure order was approved, I heard a lot of commentary that there's probably going to be a need for the FCC to provide more clarity in some areas, and that to really speak things that there may be additional work that will eventually be needed. Has anything come up since, or what's the latest thinking on the need for the FCC to take some next steps now in the aftermath of that order?
Yeah, let me answer it this way. So I think the September order that we released, I think really reoriented the state and local process back to where Congress put it in 1996 when they passed Section 233 and 332 of the Communications Act, to make sure this local process isn't operating as an effective prohibition. That said, this local process is not something that we can micromanage from DC. At the end of the day, it's going to take good faith discussions and negotiations, both on the private sector carrier side and on the state and local side, to get these deployments across the finish line. Again, I think we did exactly what we're required to do under the statute in terms of providing high-level clarity about how these discussions should go. But these are relationships that the carriers are going to need to develop, and these are just good faith, sitting down at the table and figuring out how we solve for 5G in this community, in this community. Those are things that we're not going to be able to step in and obviate completely, nor should we. But there's additional issues that come up that need further clarity. We're happy to do it, but at this point, a lot of this is going to come down to good faith discussions on both sides of the deployment debate.
Everyone join me in thanking Commissioner Carr. Thank you very, very much.
Thanks, appreciate it.
All right, why don't we go ahead and transition to our first panel, Peter? This is my
All right, sure. Good morning. After a number of years doing these panel and technology focuses on 5G, it's really exciting to be doing one where 5G is actually rolling out. I'm Peter Rasavi of Rasavi Research. I've been studying, analyzing, working as a consultant analyst in wireless technology for 28 years. When I started, I thought it'd be a nice little niche area to go into. And the technology has certainly evolved since then. I just published a new report on how 5G will reshape the broadband landscape. So this is an area that I'm actively involved in. It's my great pleasure to moderate this panel today, to have Amitabh Ghosh from Nokia, to have Derek Johnston from Samsung, Bill Lair from MIT, and Jeff Stewart from AT&T on the panel today. I'm going to begin with each of the panelists just giving a quick intro of who they are, what they do, and what their company is doing with 5G. And then we'll go into questions, and then we'll also turn it over to the audience for questions. Maybe you should just take this off and move it around.
Okay, good morning, and thanks, Peter. And, I'm Amitabh from Nokia Bell Labs. We have been involved in 5G since its inception, and part of the 5G research, we are working on 5G since 2012-13, and Nokia is very active on 5G, one of the leaders in standards, and now we will be deploying 5G for our various customers by next year. And why we are doing 5G? We're doing 5G to make our lives better. And I think every industry, starting from manufacturing to healthcare to IT, will be affected by 5G. And so that's what we do. We do standards, we do trials, we do requirements. We work closely with our customers and with operators. So, and 5G is really for deployment.
Good morning, Derek Johnson with Samsung. I'm with the Networks Division, which is a lesser known program with a huge conglomerate. It's basically for you guys have heard. My focus is on marketing and business development, 5G business development specifically. So for the last few years, I've been involved in a lot of the testing and trialing we've been doing with operators here in the U.S. Similar to Nokia, we have been at the forefront of researching 5G. And specifically, we're starting now to establish test beds in manufacturing and healthcare, as we've got different lines of business, particularly global manufacturer in things like semiconductors, network equipment, devices. And so we've got a broad-based experience in both of those areas. So we look forward to today's discussion.
Hi, I'm Bill Lair. I'm an economist in the Advanced Networking Architecture Group at the Computer Science and Artificial Intelligence Lab at MIT. And we're sort of interested in everything to do with 5G. 5G is the next step to a lot of things. The next step to really realizing the future of pervasive computing, which is sort of everything, always, everywhere, connectable. And if that happens, that vision is realized, which it better be realized, then all these sort of wonderful things that we'll talk about, where it could be anything is potentially becomes available. I'll be talking also about healthcare and some of the specific projects that MIT works on. But I'm interested at MIT, they're developing, it's not just the markets and what happens there, but it's all the other stuff. Because once you solve a bottleneck in one area, then you do it everywhere else. So 5G is necessary for artificial intelligence, robots, and autonomous vehicles, and all that sort of stuff. So we'll talk about that.
Good morning, I'm Jester with AT&T. I'm in our global public policy organization that support our wireless and Internet of Things solutions organizations. So IoT is certainly one of those areas that touches both healthcare and manufacturing that will certainly be greatly impacted by the deployment of 5G. Obviously, AT&T is one of the major carriers here that is on the forefront of deploying 5G in this country. And we've been, as Nokia, we've been very active in the standard organizations and helping shape the development of the 5G technology itself. So look forward to the discussion this morning.
Tom and I will share this mic, and you guys can share that one.
Poor Derek, I hate you all
All right, let's begin with what is the current status of 5G standardization and deployment? Maybe Amitabh, you can talk about standardization.
Okay, so release 15, so this standards is being done in the 3GPP standards project, or 3G partnership project. So release 15, so it is based on releases. So release 15 is the first release of 5G new radio, we call it new radio. And so both non-standalone and standalone architectures have been standardized. And 3GPP is now working on release 16, so which are enhancements to the 5G new radio features. But the 5G new radio, along with LTE, will be ready for deployment across all spectrum bands, low bands, mid bands, and also at the middle bands, hopefully next year.
Jeff, maybe you can comment on actual deployment. And
Sure.
when people might be able to touch it, feel it, try it.
It's coming very soon. AT&T has announced the initial deployments in parts of 12 cities by the end of this year. So those deployments are being built out right now. And with 7 more cities early in 2019, again with initial deployments in parts of those cities. And these initial deployments will be based on millimeter wave deployments. So they're initially going to be fairly small scale, covering some of the very most densely used portions of those cities. And then, so that's beginning right now, and other companies are certainly following through with parallel kinds of deployments around the country, different locations. Also, in parallel to that, an important part of it, Commissioner Carr had mentioned it sort of as well, our overall small cells deployment that is addressing not only preparations for 5G, but is bolstering and intensifying our 4G LTE networks. And so that's another very significant component of deployment. And that's on a much broader scale. So we have deployed what we're calling 5G evolution, which is LTE advanced technology that provides up to 400 megabits throughput for existing LTE networks. We're deploying that to up to 400 markets by the end of 2018. And then LTE licensed assisted access, another version and expansion of the LTE technology using that incorporates licensed spectrum with unlicensed spectrum. We're deploying that as well, and we'll have 20 cities by the end of the year. So all those things, parts of the deployment will feed into laying the groundwork for broader 5G deployment in years to come. But those initial 5G deployments are really beginning for mobile using millimeter wave here by the end of this year.
Thanks. As long as we're talking about deployment, what was mentioned, or what Commissioner Carr referred to as the different spectrum bands, the 3 tiers of bands, millimeter wave, mid-band, and low band. How will 5G, how will these different bands create different versions of 5G, or what will 5G look and feel like in these different bands? And maybe, Derek?
Yes, we've done a lot of work in specifically millimeter wave, as I've done as well as with Nokia. And so the things that we've learned over the past 3 or 4 years, and more specifically last year within the trialing, and now we're going into commercial service with a lot of operators like AT&T, is that when you get up into the 28 gigahertz or 39 gigahertz that have been identified here in the U.S., is that these small cells, realistically can throw a signal for about 2,000 feet and maintain kind of multi-gigabit level service. But there's also been using beamforming technology to help do non-line of sight by kind of bouncing the signal around. So those types of deployments for millimeter wave are really good for this really high capacity, because there's huge chunks of spectrum that are available, and for that real low latency that you hear about, that really quick speed, getting from point A to point B to support things like streaming high definition video. And so that layer, I think, of the network is what's being contemplated for those types of applications. And then as you get down in the lower band of spectrum, like the 600 or basically what's being referred to as sub-6, that's more of your broader kind of coverage capacity, your enhanced mobile broadband for your device uses, things where the propagation, the signal propagation will help travel through buildings a bit better than millimeter wave has shown. So that's more or less the breakdown.
right, let's dive into the specific areas of healthcare and manufacturing. What are the specific features of 5G that really increase the scope of wireless usage in healthcare and manufacturing? In other words, what is it about 5G that applies or can be used or enables these industries?
So, one of the things I want to make it clear that 5G is not only millimeter wave, it is low bands, mid bands, and millimeter wave bands. Now, the question is, what are the features in 5G compared to what we have in LTE? So, LTE release 13 and 14 had massive MIMO. 5G new radio also had massive MIMO. So, I think one of the great features of 5G is about deploying massive MIMO in mid bands and in millimeter wave bands, which will enhance the capacity and various and the operator experience. Then, with respect to the IoT application, the first application of 5G millimeter wave bands is the fixed wireless access. So that is the first. In addition, one will see the proliferation of private networks in industrial IoT applications. And the other thing I like to point out that 5G is not about radio, it is end-to-end. So you have this new concept of network slicing, where you can have your own network geared towards some applications which will call it a slice, which will have its own quality of service, and you can bring up or take down that slice very easily in 5G. So 5G is end-to-end experience, including, which will include machine learning, supporting various IoT industries, network slicing, and various features, and one of the features is massive MIMO, covering all bands.
anybody want to add to that? Bill, why don't you take that mic there?
Yeah, so, I mean, as the economist who doesn't understand all the technology stuff, you know, the things that they talk about are, they're very, very high bandwidth. So it's order of magnitude improvement. A lot of the business models and things you want to do today, you could do in 4G, but you can't do them anywhere near as well, and you won't see anywhere near as demand. And if we stop and wait for those markets to develop before we do 5G, then by when those markets do develop, we won't have what we need. So 5G is sort of racing along at the same time as other markets are developing, but the dramatic increase in bandwidth is so that you can do really high-speed interactive video, and you want to do that if you want to do, for example, things like remote operations and things like that. Very low latencies you also need if you want to have much more responsive remote control, like, for example, if you are actually trying to operate on someone in Africa from Washington, D.C. Wireless, because, you know, you want this Internet of Things, the ability to support massive numbers of devices, because you've got all kinds of devices, little devices, embedded devices, in your environment, on your clothes, everywhere. You want to make those be possible to be supported. The slicing is really important because a lot of these different applications are going to have very, very different security requirements. So you're not going to want necessarily whoever's handling your insulin pump to be putting that and mixing it with, let's say, entertainment traffic. And you're going to want to know that someone's managed that on an end-to-end basis. And the kind of slicing capabilities they're talking about is critical to doing that. Reliability, there's a lot of capability to support reliability. Not only the diversity of connectivity and do sort of robust routing, the ability to over-provision in many different ways. And, you know, what you're trying to support is going to give you the kind of reliability that you need if you're going to put sort of mission-critical things like healthcare or control of electric power plants, things like that, on these grids. And I mentioned also the support for just many, many more devices. The first, you know, sort of generations of mobile telephony were about providing a personalized communication device for everybody, so 1 and 2. And then 3 and 4 were about really getting mobile broadband together. 5G is about tying together the this ICT world with the real world and really linking those things together. And it's not going to be 1 or 2 or 3 devices per person. It could be thousands of devices per person, and devices talking to other devices. That's the thing we're trying to build infrastructure for.
Okay, thanks. Let's continue discussing use cases for healthcare and manufacturing. Derek, Samsung has a manufacturing innovation test bed that you're working on with AT&T. Can you give us some details about that?
Sure. Yeah, back in September, we had announced a collaboration with AT&T as well as our Austin Semiconductor facility. So we recently became a customer of AT&T, I'm happy to say. And so part of that initial outcropping of that commercial agreement was this test bed that we set up, or that we're in the process of setting up. And as I said, it's based in our Austin Semiconductor facility. And what we're endeavoring to find out there is using our own semiconductor facility with AT&T to establish a variety of different applications that could help drive kind of the next level of innovation in manufacturing. And so what we're doing right now, and actively involved in the project, is we're establishing some of those test cases and those use cases. Things like using 4K video with analytics to make sure that or even tying it into the manufacturing facilities security system. So obviously semiconductor facility is highly secure, and so we're using kind of 4K streaming video with an analytics overlay on it to over 5G network in order to test and see if, again, the latency capabilities are there, things of that nature. The other piece of it is the IoT components. So this kind of manufacturing facility with silicon is, highly needs to have a highly controlled environment. So things like humidity, temperature, vibration, putting a bunch of these sensors wirelessly enabled, bringing those over the 5G network as well. And then lastly, we're looking at kind of AR and VR applications for technicians as well as training. So we have a lot of new hires that come on board using VR via the 5G network to give a more immersive experience to those new hires that are involved in highly technical training, as well as our technicians out in the field using kind of AR via tablets. So in other words, we're working on something on the production line, and you need to identify what parts need to be use the camera, overlay it into the analytics behind it, and then identify what the areas that needs to be fixed and recommend to fix. So these are the kind of test bed applications that we're trying to establish, and then take those learnings and put them out in the field practically for the manufacturing segment to use.
Great. Jeff, can you maybe elaborate on what you're seeing for both manufacturing and healthcare using wireless connections and how 5G will play a role?
Sure, certainly. We've had a couple of recent announcements of proof of concepts in the healthcare space that are current here, and these are actually currently using 4G LTE, but they show sort of the promise of what can happen and sort of that scale of 5G. One, we did a pilot with drone delivery of medical supplies that require controlled conditions, so temperature controlled and shock sensitivity controlled devices, so that they can be delivered into remote areas. We actually did this in Puerto Rico, using non-onsite control or using 4G LTE network control for drone delivery with that continuous monitoring to ensure that the supplies are being delivered and that they're still going to be useful when they're delivered on site. Also, on the sort of the IoT device, a lot of focus for 5G gets put on the enhancement of broadband, the high throughput, things like that, but a lot of IoT devices don't require that. They require very limited amounts of telemetry to go off the device, very small bandwidth, and they need to be long duration and long life because they're operating with batteries that don't want to be replaced very frequently. So a good example of that we've done recently is a pilot with a prosthetic company called Hanger that allows the embedded sensors to be put into a prosthetic lower limb that can then monitor the usage of that limb, provide data back to the manufacturer on how it's being used, patients' conditions with it, and that can help drive improved product development and delivery for that. And that kind of sensor, like I said, that doesn't require a whole lot of bandwidth, but does require a long duration, a lower limb is going to last for a long time, so that sensor needs to be able to be very power efficient. And there's things in both the current 4G standards and prospectively in 5G as they get deployed for that machine type communications that expand that utility.
Okay, thanks. And Bill, can you tell us what MIT is up to with respect to healthcare and connectivity?
Sure. So I looked, and talked to a couple of folks in my lab. Interestingly, the three people I'll talk about are all women at the top of the field, all doing really amazing work. The first one is Dina Katabi, and she's done a lot of really great work in wireless, including things about how to scale Wi-Fi technologies linearly with a number of base stations. And she does this by doing a lot of stuff at the radio layer. And one of the things she's been working on is this latest project thing called RF Pose, which allows you to do non-invasive monitoring. So basically by sending a bunch of high-frequency radio waves into a room and then getting all that complex data out, she can infer and learn all kinds of things. So she can monitor breathing and heart rate and other things like this, people's attitude and positions. And RF Pose is about learning about those attitudes and positions. And the way they're training the radio algorithms so they can do this in radio space is by analyzing pictures. So there's a lot of machine learning types of activities going on here, but also deeply embedded with the wireless. And if you think about sort of going to a future of personalized healthcare, one of them is monitoring, the ability to non-invasively, continuously track data in real time, like the Dr. Carr, Mr. Carr was talking earlier about the insulin pump monitoring that was going to Mississippi. Well, you could do this for anything, and you could do this in all kinds of ways. So that monitoring capability, Dina Katabi's work is extending that. She won a MacArthur Award, I think, a couple of years ago. Someone else is Regina Barzilay, who just recently won the MacArthur Award, is in the lab, and she's been using AI, big data techniques, machine learning, to analyze different sorts of data on, diagnostic data on breast cancer. And she's figured out ways to make those sorts of tests much less expensive, much be able to detect things and anomalies, because when you get those kinds of the ability to capture the kind of image data, the video data, or the very significant amounts of data that 5G types of technologies allow you to get, you have to figure out what you do with that. And so she's doing that. And then Daniela Roos has been working on ways to figure out how to thin the data to extract the information. So there's a ton of laparoscopic video that's taken in operating rooms, and they don't know what to do with this data. You can't process it. And most of the time when you process images, you need a human to look at those images. So what they're doing is using machine learning techniques to extract stuff from these video streams, and then that can allow them, by feeding it up into the cloud, can then potentially allow them to better develop real-time abilities to diagnose stuff that can then feed back into the teleoperating rooms and all of that. So, you've got both the monitoring stuff that 5G is enabling, you've got the decision making, the ability to pull this data up into the cloud and throw all the big data analytics, artificial intelligence, machine learning sorts of capabilities, crowdsourcing of this data to learn from these things and see emergent types of things. Of course, everything you do in healthcare, you could also do for energy or terrorist attacks or anything else. And then you have the real-time control stuff, the ability to have low latency so that you can then put this decisions in the hands of people to help them, augment their reality.
Okay, thanks. I'd like to spend a couple of minutes talking about quality of service and what you see as the importance of being able to manage the network in real time, how traffic prioritization may relate to network slicing, for instance. Is that something you can comment on?
Yes.
So let me focus on industrial systems, which are complex ecosystems of equipment and personnel. So network slicing provides virtualized and specialized network solution players with different needs, access rights, and prioritization, all in one infrastructure. So we have been demonstrating this with key partners. Among them, I just want to mention the automation of Hamburg port, which we are doing in collaboration with Deutsche Telekom and the Hamburg Port Authority, as well as a collaboration with BMW on how to support automotive application, like, for example, autonomous driving and infotainment. So this network slicing is one of the key features in 5G, as I mentioned, where we are able to use established network slices for different applications with the own QoS.
Okay, thanks. Derek, is there anything you can add to that?
Yeah, I think, when you look at specifically as it relates to healthcare and manufacturing, quality of service is obviously super critical, particularly in healthcare. As we mentioned, when you're looking at all the various connected elements in a healthcare facility, and you look at your average room from anywhere where an outpatient sits, has got anywhere from 5 to 7 LAN connections, and that's a room where you're kind of, as an outpatient, you're moving out of the facility to, your critical care areas, where they could have 15 to 20 LAN ports in that room just to support all the connectivity. And so for 5G to be able to really make a difference in healthcare, you're going to have that quality of service, whether it's via network slice or it's a private, 5G network that is offered to a huge healthcare facility to be able to manage those applications that are either delivering critical care or not even necessarily critical care, but still need that high level of connectivity and resiliency. So I think those in manufacturing, obviously the same situation in terms of production line and security, things of that nature. It warrants either a slice or that high level of over provisioning in terms of capacity, or even just reliability in general, to be able to support those applications.
Another interesting aspect of the change with QoS in 5G is that in 4G standards, QoS provisioned on a bearer basis. So you have a bearer established to an individual, end device. And in 5G, that transitioned to a data flow quality of service. So one device can have, I think, up to 8 different separate connections. And each of those data flows can then be multiplied together. So it makes a more efficient use in providing the quality service you need with a greater diversity and scale of devices available. So, the quality service ranges from very high end to deliver that ultra reliable low latency communications you need for near real-time type services. But then the enhancements of QoS architecture in 5G also allows that greater efficiency to still be able to provide that at massive scale and provide that very small amounts of data on a more economical basis for the low-end type devices.
Okay, thanks. I'd like to spend a few minutes talking about AI and its role in 5G. Derek, Samsung has a new AI center in New York. Can you just comment on that and how that may relate to 5G?
Sure. Yeah, we recently opened up, I think this is our 7th global AI center in New York under a gentleman named Dr. Lee, who's got, maybe from MIT, I believe. and has a focus on robotics and machine learning, and so I think that's going to be the focus of this particular AI center, but it's an area that Samsung has been deeply investing in, I would say the past 4 to 5 years. Each of our AI centers are usually centered around some higher learning facility. So, for example, in Cambridge, in the UK, we have a cooperative relationship with Cambridge University. I suspect the same will be for this center in New York, potentially with NYU, and so in their AI lab. But specifically as it relates to AI, we touch a whole variety of different areas, everything from an acquisition we made with Bit Labs a while back to, we have our own voice assistant in terms of Bixby that we use in our devices, to we're using AI in a lot of our network equipment for everything from beamforming technology that's using advanced algorithms to our planning tools we're using with operators to help design the network. And so AI is a big area of investment of interest to us.
Okay, thanks. Any of the other panelists want to comment on the role of AI with respect to 5G?
Well, I think AI, machine learning, also we call it deep learning, and there are some certain differences between. The ultimate goal is to improve operator experience and simplify network ownership. So that is the final goal. With respect to RAN technology, now we have a densified network which will comprise of macro cells, pico cells, micro cells, covering different bands, and instead of, say, 200 parameters, now we have to control 2,000 parameters. So AI will help in controlling this network and make the network deployment much more simple. For example, in millimeter wave, one of the problems is blockage. So you can be blocked by a human body, a car, so you have to have connectivity to multiple base stations to make this seamless handover work. So what artificial intelligence or machine learning can do is to predict there is a blockage and make some corrective action. So that's one of the advantages we are studying with AI, how to simplify network deployment.
Anything from any of the other panelists?
Well, I would just say that, when I was talking about tying together the real world and the virtual world, if you actually do that, it's obvious, if you think about it for more than about a second, that a lot of that has to be automated, and you want it to be unaware. You don't want to know when, your device figuring out is it buffering more and changing the codecs or whatever. All that stuff's being done by computers in the background figuring that stuff out, and that's AI. And it's going to be everywhere, it has to be everywhere. And it's not just, when you do this, you're processing this data, you also need to change a lot about the architectures. And in the networking space, people talk about, we heard about like the rise of clouds, well, and then it was different kinds of clouds. And now the current thing is anything as a service. So whatever it is you want, you can get as a service. You can get cars as a service, you can get CPU cycles as a service, you can get Spectrum as a service. And that's all going to be managed and coordinated through AI, which of course also raises a whole lot of interesting questions.
Jeff?
Just one quick point on that, also from the operator point of view, is what enables that for us and its application on our networks is the transition sort of corresponding with the evolution from 4G to 5G, transition to software-defined networks, so that our networking equipment is no longer purpose-built equipment that's physical in our network, but has been virtualized into white box type computing platforms that allow the AI to function on it and allow far greater flexibility in the deployment and operation of the network.
Okay. So Karen, we're going to 11:15, is that correct?
Sure.
Okay. Well, I think at this point, we'll see if the audience has any questions. So if you could state who you are and who you're with, and then your question. And then if we run out of questions, I've got more, 3 pages here. Beginning with Carolyn. There's the mic.
Carolyn, Georgetown. For those of us who were English and philosophy majors in the audience, I would like to just ask what for this panel would be extremely basic questions, but might be very helpful. One is, can you give us sort of a very easy to understand idea of what network slicing is? Those of us who are in the space get it, but those of us who are not,
network slicing. Amitabh, you already you introduced network slicing. Can you maybe just provide a kind of slightly deeper explanation?
So to view that simply from a layman's point of view, you have different quality of service requirement for different kinds of applications. So what network slicing does, so industrial IoT applications, so 5G can have a specialized network slice for that particular application with their own QoS, with their own characteristics. And you can establish that network slice very easily, and you can then dismantle that network slice very easily.
So telemedicine might be a network slice.
Say again?
Telemedicine.
Telemedicine can be a network slice. So, and then there are other applications. So V2X, vehicle 2X or V2V can be a network slice. So all these applications, each application, so manufacturing can be a network slice. So is that clear?
What's the operator perspective on how you might make network slicing available to your customers?
Sure, they're, yeah, right, it's a logical partition of the network into different sets of characteristics that are matched to the services that are being demanded. As Amitabh said, it can be stood up very quickly and torn down, but it also allows that sort of greater multiplex use of cars and VDEX communications. If you think about all the kind of things that are being communicated to and from cars, VDEX communications would be one element of that, but so would mobile broadband entertainment. So you have to slice mobile broadband to transmit video to the vehicle for passengers, and then at the same time you have safety critical information being transmitted on a different slice of the network potentially. And same thing, that same kind of application can be found throughout all the different verticals. Manufacturing, the cameras that are very high bandwidth would need one slice. Sensors that are only intermittently reporting basic kind of data could be on a totally different slice. It allows a more efficient use of the overall network resources.
Okay. So then your question about machine learning and how that relates to AI, maybe Bill, you can elaborate on that.
I mean, I don't think that AI is much larger than just machine learning. You were also talking about machine-to-machine communications, and that's certainly a lot of what will be enabled by AI, but obviously that's not the only thing. And one of the challenges that is being grappled with and sort of blurring the boundary policy is that when you design AI systems, you have to figure out what do you mean by the system. And in the earliest, first generations of these, they didn't think about the users of the system. And increasingly, as you embed this more in society, you have to actually think about the users of the system as part of the system and offloading to the humans, actors, what they're going to do. And a lot of things humans don't do. It's like when you're in your car and you push on the brakes in today's cars and it feels like you're skidding, get that haptic response. That's all digitally generated. That's not real hydraulics. And that, those sorts of things are going to be taken into place. But AI covers a whole lot of things, from robotics, to the design of the basic software languages, to the coding algorithms, to the fundamental math. The statistics of how you analyze data sets, they're no longer assumptions of classical statistics, means we have to really rethink everything. And so, for example, economics, empirical economics, is basically going through a sea change now because of the mergers that I did there.
Okay. Back to audience questions. Anybody have a question over there?
Thank you very much. As I mentioned earlier, I'm working with the World Bank, and we are working in the developing world mainly. If I put the same title from the developing world's point of view, what do you think could be the applications, especially in the healthcare, which is a very, very challenging issue in most of the developing countries? How do you see the combination of 5G and artificial intelligence and all these technological developments which could be applicable? And by the way, in the World Bank, we have introduced what is called the disruptive technology group. And there is a lot of focus on that how these technologies can help in development. Thank you.
Anybody?
Yeah, so you know the basic features of 5G, there are three basic features. Is mobile broadband, which is capable of very huge data rates. The second is ultra reliable low latency communications. And the third is massive FTC, which can be satisfied by our LTE network. So one of the applications from a healthcare point of view is monitoring various parameters within, for elderly, say, people have a lot of elderly patients everywhere. So 5G enables through, because it can support a lot of huge number of IoT devices. And what you can do, you can monitor the presence using localization, health monitoring, the heartbeat monitoring, and then you see what it was mentioned at MIT, they're doing this presence that you can monitor the heartbeat remotely. You don't have to wire any gadgets. So, and you can transmit that data to the central facility where you can go there, you can monitor the health of any individual without going to the medical facility, which are difficult to access in developing world. So that probably is the advantage of 5G, because 5G provides huge capacity and probably LTE also does that. But these are the these features along with huge capacity and how it integrates with the IoT devices will help the developing world with respect to healthcare benefits.
Go ahead, Bill.
There's a time, first of all, 5G is something that we are inventing now, so there's a real opportunity in the developing world for them to leapfrog in different parts if they choose where they want to compete. But like certainly all kinds of sectors like natural resource development, agriculture, managing, irrigation, all that sort of stuff is really going to benefit from 5G sorts of sensing technologies. It's not just about communications, it's also about sensing, the ability to use many different kinds of bandwidth, so like for example integrated satellite bandwidth. 5G opens a much larger toolbox of possible ways to deploy networks. And so we're someone in the developing world who doesn't have any kind of real network capability. They have a 4G network. They probably wouldn't build a 4G network. They would probably think about building a 5G capable network. And so, there's a lot of opportunities in that way. And then obviously also in education, this opens up the capability of dramatically changing the opportunities to sort of developers. And like there's a development project that we have in India at the Sloan School where we're developing tech for the developing world. And they've set up fab shops in remote parts of India and things like that, and having kids learn how to design chips and all that sort of stuff.
Okay, thank you. Other questions? Anne Marie?
I'm Anne-Marie Kovacs. I'm with the Georgetown Center. Obviously 5G has some phenomenal potential, but it also, I think, raises some issues of privacy, because you're looking at healthcare, for example, and security, where you're looking at huge numbers of devices. Can you talk a little bit about how those issues are being addressed?
Go ahead, Jeff.
Part of me wants to just punt to the next panel for policy discussion.
That's fair.
But I am a public policy guy, so I will take an initial stab at it. I think in part, there are definitely some benefits to both privacy and security that 5G offers. We discussed network slicing. That's one of the manifestations of benefits for security, is those slices can have different attributes, and that partitioning between different traffic types can help provide an additional degree of security, so that your health telemetry off of a medical device is logically separated and partitioned off of other sort of generalized internet traffic. So that provides a slightly greater degree of installation for a security perspective. Privacy-wise, that is a much larger issue, and the scale and it goes well beyond simply the networks, because there's just so much data that's being generated by so many different kinds of entities. I think that we in this country and around the world are trying to grappling with sort of what the right frameworks are for addressing that. And 5G plays a role in that, but it's by no means sort of a dominant factor in the privacy concerns there. And it's more, I would see it as sort of an extension of what we're already facing with the amount of data that's being generated from mobile devices, and the already a very, very large number of connected devices that exist. So it'll further scale the questions and issues, but it doesn't, I don't think it necessarily truly transforms the issues as it pertains to privacy per se.
Okay, thanks, Jeff. Another question?
Hi, Alex Wiltz. I'm with Reorg M&A, and I'm new to covering this kind of stuff. So I was just wondering, how long is it going to take to deploy these 5G networks? Like, when do you expect people will be able to start using it? I know, kind of like, I have 5G in my house, but I guess more complex versions of the networks and things like that. Thanks.
All right, Derek?
Yeah, so you've already seen, probably you've seen some announcements out there recently. Verizon was one of the first to announce a fixed wireless application for 5G. So Sacramento, Houston, Indianapolis, and there were four cities that have 5G and using it for fixed wireless, which is essentially wireless broadband to your home. That was one of the first use cases. As Jeff mentioned, AT&T started to launch their networks. Sprint's gotten to launch their massive MIMO solution, so across their network, which is going to be 4G initially, but then they can software upgrade to 5G very, very quickly. And so I think the thinking is that 2019 will largely be a build year. Most of the kind of major metro areas, all the operators have announced that they're building out their networks in earnest. 2020 is probably when you get to kind of a broad availability of 5G for mobile applications. In terms of the standards-based 5G, and again, it still will not be out in your rural areas yet, but again, that's kind of able to start in dense urban areas and then move to kind of tier 2, tier 3 cities and such.
Yeah, I think the 5G deployment, we constantly hear sort of race 5G. That race is not a 100-meter dash. It's much more of a triathlon kind of race with multiple phases and a very long time period. So as Derek was saying, yes, this end of this year we'll have 5G deployed for mobile broadband in a few select areas of 12 cities. The expansion beyond that will be, transitioning to once we're able to, we and other carriers are able to get 5G deployed in the mid and low band spectrum. That will provide greater coverage. But that's going to be kind of a different phase of the build. And then also the standards for release 15 were completed that allows this mobile broadband to be deployed now. And the standards were actually accelerated in the end of 2017. That's enabling us to deploy as early as it is right now. But the standards for release 16 won't be completed until the end of next year. And that's going to sort of finalize and set the standards that will enable the next couple of phases of 5G to be deployed. So that does sort of extend that timeline out into the early 2020s before it's sort of full phases of all the different attributes of 5G that we've been talking about are available more broadly.
Okay, final comment by Amitabh.
Yeah, so there is a rule of thumb, right? So if the standards is completed, say release 15 was completed this year, 2018. So we'll see full-scale commercial deployment after 2 years after every standards is completed. So release 16 will be completed next year. We'll see release 16 features coming after 2 years. So that is the basic rule of thumb.
Well, sorry, Neil, we're out of time. And thanks very much to all the panelists for their excellent observations.
I'm going to steal, Peter, your approach and let each of the speakers introduce themselves real quick. I'm Carolyn Brendan. I'm from the Georgetown Center. Have been with the center for a number of years, and I'm very, very excited that we are in year number 6 to do this tech and policy combination of an event. Because very often in this town, the suites of issues are often separated, either talked about solely from a technology perspective or solely from a policy perspective, and we're trying to bring the two together, because you can't do one without the other. All right, so before we get into it, and as I said, sort of half jokingly, we almost have a new conversation based on the holdover questions from the first panel. I was hoping that each of you, I know, right?
If we could just, each of you introduce yourself, and if you have any initial comments and thoughts, just any reactions to the first panel before we dive into what we were planning to talk about here.
Hi, I'm Neil Chilson. I am at the Charles Koch Institute, where I head the research. I'm the Senior Research Fellow. I'm still getting used to this. It's a new job. Senior Research Fellow for Technology and Innovation. And we work on a bunch of different things, but the three areas that we focus on are cultural impacts of innovation, digital free speech and free association, and barriers to innovation. The last category is the sort of regulatory issues that are probably most applicable here. Prior to this, I was the acting chief technologist at the Federal Trade Commission, and I was an attorney advisor to acting chairman Olhausen, both in her roles as acting chairman, and then previous to that as a regular commissioner. I'm glad to be here, and I'm super excited about 5G.
Thanks very much. That was a terrific panel to start with. I could have listened to it all day, but instead we had to go on too. I'm Mike Mandel. I'm the Chief Economic Strategist at the Progressive Policy Institute. I'm also a Senior Fellow at the Mack Institute for Innovation Management at Wharton. We are concerned about the policy and economic implications of 5G, and especially on the ability of 5G to help accelerate productivity growth in the physical sector. One of the things that we look at is the differential rate of growth between digital industries and physical industries, and productivity. Actually, new data just came out today, which is why I've got my computer right here. The physical industries have had extremely slow productivity growth, and there's a lot of reasons for that, and 5G is going to help accelerate productivity growth in industries like manufacturing and healthcare, which have been remarkably slow, and is going to lead to what we talk about as the Internet of Goods. Not the Internet of Things, which sort of focuses on the technology, but the Internet of Goods, which focuses on the flows of physical goods around the economy and the development of new business models and the creation of new jobs geographically across the country in a way that actually helps areas that have been left behind.
Good morning, I'm Jackie McCarthy, and I'm with CTIA, the Wireless Association. Our members include the carriers, device manufacturers, component suppliers, and app developers in the US wireless ecosystem. I've been at CTIA for about 10 years, and I focus on connected life sectors. So these are Internet of Things sectors, and I lead our public policy and advocacy efforts in areas like connected cars, mobile healthcare, smart cities, and drones. And I'm excited to continue the discussion.
Jackie, if you will hold on to your microphone, because I'm going to start with you, and I'll let you just pass me. And the microphone, I know most of you can hear us, it's mostly for the taping, because our discussion will live on into eternity on the internet. Scary as that might be. Jackie, if you could, what we heard on the first panel was really exciting, and, it's focused on what's going to ride on top of these networks, as well as what the networks themselves will be capable of. But can we just go back to first principles and talk a little bit about spectrum? Because without the spectrum available, this isn't going to happen. So can you give us a sense of where are we with respect to the actions the FCC has taken to make spectrum available, what you see coming in the near future or over the next couple of years to keep that spectrum pipeline full and to be utilized and leveraged by 5G infrastructure?
Sure. As we've heard throughout the morning, spectrum is really critical for meeting the growing demand of today's wireless users and deploying 5G networks, and we really do need a robust and long-term pipeline of government and commercial spectrum. And the good news is that with respect to both, or with respect to all of high band, mid band, and low band spectrum resources, we've seen some really positive and significant developments in the past year or so. In terms of high band spectrum, which I've heard described as a sprinter in terms of it going at short distances and high capacity, FCC Chairman Pai announced a total of 5 band high band auctions starting this fall through the end of next year. This is a really great development because at the beginning of 2018, there were 0 high-band auctions in the pipeline. With respect to mid-band spectrum, which is really attractive in terms of its ability to provide both capacity and longer distance coverage, makes it very attractive and is attractive globally for 5G deployment. Last month, the FCC adopted mid-band spectrum reforms to the 3.5 gigahertz bands, and this includes lengthening the license terms, creating larger geographical license areas, and creating a presumption that those licenses will be renewed. And they really did a great job of balancing the need to make these bands investment-friendly for licensees, but also maintaining the fact that the 3.5 gigahertz band is intended for experimentation and is also about half reserved for unlicensed uses. Also, we're seeing the FCC exploring the availability of 3.7 to 4.2 gigahertz bands in the mid-band category. And then finally, the long-distance runner of the group, the low-band spectrum, we're seeing in the marketplace carriers putting 600 megahertz spectrum to work. Jeff Stewart from AT&T mentioned that. And on the FCC side, the Commission is addressing some of the repacking issues that are required to get that low-band spectrum to marketplace. And in the longer term, Congress is beginning to consider spectrum at 1.3 gigahertz and 1.7 gigahertz. And that's part of kind of the longer term congressional review of a spectrum pipeline, which we're seeing in the form of the Airways Act, which creates a new schedule for up to 5 years of spectrum auctions, and which has over 60 bipartisan co-sponsors.
So Jackie, real quick, without asking you to do a lot of math here, one of the things that wasn't touched on so much in the first panel, but has been in other conferences focused on 5G, is the much wider channelization that is potentially, going to be a fantastic area for 5G. Can you just really quickly tabulate for the audience about how much additional spectrum are we looking at coming on board over the next X number of years covered by what you just said?
Yeah, I think that's best shown through that Airways Act that I mentioned. The total pipeline contemplated by that bill is over 1,000 megahertz, so it's pretty significant.
And that, obviously is a very large number, but when you consider, and this is actually going to lead to a question, you consider what some of our competitors are doing around the world and how much spectrum a 5G channel may need to be optimized, it's actually not that much. So real quick, where does the US stand relative to China, South Korea, and other global competitors in terms of making spectrum available for commercial 5G?
Yeah, in the spring of this year, Analysis Mason issued a report comparing these and other economies on 5G readiness. They looked at things like a national 5G plan, spectrum availability, and auction pipeline, as well as infrastructure reform. We heard a bit from Commissioner Carr about China's really large-scale infrastructure work. And the top-line conclusion is that currently the U.S. is the third behind China and South Korea. As we heard, China has the highest score for 5G readiness because there's a real national push in terms of carriers there committing to commercial widespread launch by 2020 and the ability to deploy infrastructure at a pretty massive rate. And then second, South Korea was really well positioned earlier this year and used the focal point of the Winter Olympics to really ramp up with their operators their 5G deployment. And in terms of research and trials, they're also well on their way. And then kind of rounding out the top tier of countries behind the US is Japan. And likewise, they're using the 2020 Summer Olympics in Tokyo as a real focal point for investment. And their regulatory authorities have committed to making high band and mid band spectrum available by early next year.
Thank you, Jackie. And just to remind the audience, the reason why we care relative to where the United States stands compared to its global competitors is because of the industries and innovation across the U.S. economy that potentially can rest on 5G, and therefore makes it a very relevant global trade issue, as well as just a general where we are in the world in terms of prices our customers are paying for what goods and services. Mr. Mandel, if we could move to you, I want to bring this sort of out of the cloud and out of the spectrum down to, as you said, the physical world. If you could share with the audience a little bit about the research you guys have been doing, and I think you were one of the first economists a couple of years ago that sort of noticed this, which was how digital networks, and in particular high-speed mobile broadband, might actually help bring actual manufacturing jobs back to the United States, if not in most places, at least to a handful of places around the country.
Yeah, so this is not. Hello? Hello? Okay, great. So, digitization. Digitization of physical industries like manufacturing and healthcare has turned out to be very difficult. Much more difficult than people expected 20 years ago. And that's had a couple of consequences. One is that we've had slow productivity growth. In manufacturing, we've actually had rising prices, and we've had very slow job growth. Basically speaking, our manufacturing industries, because they have not digitized, have not been able to compete globally, our domestic ones. Now that's had tremendous impact on living standards, on the geography of jobs, on politics, but we're not going to talk about politics today, but it's very important. We have a lot of dissatisfaction across the country connected to the fact that manufacturing has been has digitized much slower. And that part of the reason for that is that it's just very difficult. 5G is essential for the digitization of manufacturing. We've written a lot about that. We had a recent report that we did in conjunction with the Manufacturers Alliance for Productivity and Innovation, developing the idea of what we call the Internet of Goods, which is not just about digitization within the factory walls, but construction of whole new networks of business opportunities based on the fact that with 5G we can do things that we couldn't do before. And we're really starting to see the implications of this in the distribution networks. We're starting to see the implications inside of factories. Manufacturers are starting to look at these things. It's a very early stage. But in terms of bringing a manufacturing, I wouldn't even see back. It's this creation of new markets that didn't exist before in customized manufacturing, semi-customized, quick reaction, and 5G, the ability to sort of connect with processes, physical processes that are in motion is absolutely essential. So we also did a report, I can't remember, was it last year? I think it was last year on New York State, what the implication of 5G would be for upstate New York in terms of bringing manufacturing back there. You can't do this if you're just focusing your 5G in your big cities. It's about how to sort of spread it out to the places where you want to have your manufacturing operations. So when I listen to the previous panel, they're on this level, and I'm saying this is great stuff that's happening, but how is this going to create new markets and new jobs? And this is something that's happening right now.
So can you maybe, and I don't need to pull up an older report, but one of the things that struck, I think, a lot of readers of the report on New York was that, and this is why I think you were suggesting it might be replicated in other parts of the country, is you have an educated workforce that is physically close to educational resources. You've got internal ports and infrastructure like highways, so you can physically move goods and services already, and you have physical plant that has been abandoned but is still there. Given that, and then with an overlay of 5G, outside of upstate New York, are there any other areas around the country that you see as being fairly ripe for this sort of transformation with broadband?
pretty much any existing manufacturing area has real potential, because what you've got is the networks in place, you've got a skilled workforce, you've got some of the connections already. I would say that partly what new manufacturing startups especially are going to be looking for is actually areas with e-commerce fulfillment centers, which are part of the new network of the Internet of Goods. The other thing about the Internet of Goods is that it's the equivalent of sort of moving from point-to-point connections to sort of things where the intelligence is in the network, and so you can do much more things than you could before. So I'm thinking about places like Ohio and Indiana. Okay, I'm thinking about places like Minnesota. There's actually a lot of places where 5G is essential for the next generation of manufacturing.
Thank you, Michael. And Neil, not to worry, we're going to get to you in 1 second. Jackie, real quick. Jackie, I know CTI has put out other reports that try to capture the economic impact in terms of jobs, GDP impact, et cetera. Do you have any top-line numbers you can share with the audience relative to why we're focused on the sorts of growth that can happen in manufacturing, and then we'll get to healthcare in a second?
Sure, yeah. Our estimates are that 5G will result in about $275 billion in new investment, $500 billion in economic growth, supporting around 3 million jobs. And looking back to the previous generations of wireless technology, it was very interesting to hear Commissioner Carr's comments this morning, thinking back 10 years ago to the advent of 4G and how that really impacted kind of the top line economic sectors that really were the top performers. And in our industry, we look at the fact that leading in 5G relative to other markets drove an extra $100 billion into the U.S. economy, and we're seeing that lag of 4G deployment in some other markets in Europe and Japan actually led to, or was related to some economic slowdowns just generally in those markets. In terms of the impact of the FCC's infrastructure siting reforms announced earlier this fall, we estimate that those reforms will unleash about $100 billion into the U.S. economy, both because U.S. wireless carriers plan to build, as you heard earlier, about 300,000 small cells to deploy 5G over the next 3 to 4 years, and just because of, again, kind of this large-scale economic benefit of 5G across numerous sectors.
Thank you very, very much. Neil, before we get into anything related to AI and larger policy issues that could either catalyze or stall some of the cool things we're just hearing about in terms of job creation, innovation, and spend and investment, can you wear your hat as CTO FTC? How aware do you think the competition and regulatory agencies are that you come in contact with at the FTC and maybe elsewhere around town of how this technology works and what the positive implications are?
So obviously I think the FCC has been quite involved in this area given their role in assigning spectrum and regulating services. The FTC and DOJ, which are the major antitrust enforcers in the U.S., so they review mergers and they review conduct in the marketplace to make sure that it's not anti-competitive. I think they are generally aware of the fast pace of change in the wireless industry. I think there was a lot of work done. Actually, the FTC right now has ongoing workshops that are looking at a bunch of issues around antitrust and privacy and consumer protection. And I know there were a bunch of filings into the FTC that mentioned 5G as one of the things that will change how competitive markets work, both for broadband and for a lot of other services. So I think they're becoming aware of the specifics on that. Now, as enforcement agencies, they don't have to be experts until they're reviewing a merger, right? So they need to have the general idea of what's happening, but then when they're reviewing a merger, they'll dig into the markets. They'll look and see how do these technologies provide, maybe adjacent competition or possible entrants, and they'll look at that and they'll try as best they can. It's very difficult to predict what the future might look like under the merger and what the future might look like not under the merger, and try to decide, you know, does this rise to the level of an anti-competitive merger effect? So, but I will say, at least the FTC in particular is very aware of these trends. I mean, when I was there anyways, I worked on some speeches for my boss that involved some of this. And one of the stats, and I'll pull a Commissioner Carr trick and look back 10 years. One of the stats that I came up with when I was putting a speech together for my boss one time was that this was in July of 2017, so it's a little outdated, but I have the updated number. In 2017, wireless, the average speed for wireless was 3 times the average speed for wireline in 2007. So in 10 years, your home broadband connection was 3 times slower than your average wireless connection was in July of 2017. Now that stat is 5 times. So your phone now is 5 times faster than your home broadband was in 2007. To me, that shows how fast this space is moving, and I think I think that the agencies are generally aware of that and very interested in figuring out how that specifically applies when they review conduct and mergers.
Thank you very much. All right, so what I actually invited you to talk about today, which was, can you share your thinking around how policies that are starting to certainly be hotly debated, but are starting to emerge around privacy and big data, and how that policy discussion can shape the future potential of what 5G and things that are resting on 5G networks are capable of?
Right, so you know the FTC is the primary consumer protection agency enforcer in the U.S. and that, under that rubric has brought a lot of privacy and data security cases, and they've looked at the issue of big data and AI in some detail, both from the perspective of IoT. There's an IoT workshop and report, and then from the perspective of data brokers and lots of other big uses of data, as well as some of the different uses of data. Now we're hearing something different, right? That was the FTC's approach. Now we're hearing a lot about legislation. And I guess I'd start with one prior, that if you don't agree with me on this, you're not going to agree with anything else I say, which is that technological innovation has been the major driver of widespread prosperity over the last 200 years. And therefore, it's really important to make sure that the policies we put in place enable continued innovation. And if legislation makes, as we heard in the previous panel, big data requires lots of data. I mean, AI also, some of the AI mechanisms, algorithms, not all of them, but many of them require massive amounts of data, including the ones that are the most productive today. They need lots of data. Now, when people hear that, they often get nervous. For many of these applications, including the ones that might be managing, you know, how your network is working, the types of data that they're using are largely industrial data. We're not talking about individuals' data for the most part. For other types, perhaps health applications, we are talking about individuals' data, but AI generally doesn't care so much that my name's Neil Chilson. What it cares about is a certain set of parameters that are coming out of me and how those compare to everybody else in the world. So, so that data by itself is not particularly useful. It's not particularly useful to me. In fact, it's most useful to me probably if I give it into this big database where then they can look at big trends and say, hey, well, here's services that we can offer. Here are people that have similar characteristics to you, and here's what the sort of steps you might need to take to improve your health. All of this is to say, if laws around privacy and data security, and I would encourage people to think about those very differently. They're really different issues. We know a bit better what data security looks like. Well, I should say it this way. Well, we know I think everybody generally agrees what the world should look like under good data security, right? No breaches, no unauthorized access to data. Under privacy, there are really different views for how the world should look. There are some people who think that there are business models out there that just shouldn't exist. And there are some people who love, you know, certain business models. And so, so data security, privacy, I think it's easier to keep them separate. Again, the big point, if the laws that come down make it more difficult for companies to use data to make some of these big data or AI tools, that's going to have a cost
it may have a privacy benefit, but it will have other costs. And it's really important to weigh those. And if, like me, you think that it's largely technology and technological innovation that has driven progress, we should weigh heavily in that, on that side. And I bet Michael has some ideas around these issues as well, but that's kind of my big take.
Michael, I did see you nodding in agreement, and I think you guys released a lot of papers, let's just say that. Didn't you release something recently in Brussels around the effects that GDPR might have on data flows and what the implications of that are?
We released a paper on the implications of the interaction between GDPR and Brexit. Okay, but let me just, that's a whole nother mess altogether. I mean, really what's going on is three models globally for how you handle privacy. One is the European model, which is the GDPR, and as it goes into effect, and we haven't seen the full effects yet because the relevant agencies are just gearing up now, is going to definitely have an impact on innovation there. There just isn't any doubt about it. You've got the China model, which is basically wild, wild west. And then you've got the US kind of in the middle, and we're trying to find our way to what the best option is, because as Neil says, we value innovation, and actually, if you sort of look at the data, the main thing that physical industries like manufacturing suffer from is a lack of innovation, not too much. We've had a lot of innovation recently in the e-commerce space, and has generated 400,000 well-paying jobs at e-commerce fulfillment centers. And we don't want to put in laws that impede innovation, but we do want to be responsive to people. And I think we're working our way through these issues at this point. That it's, in some sense, this is related to the 5G, because the pull for 5G from businesses is also related to what sort of use they can make of it for new business models. If they are discouraged from innovation, or if they are impeded, then there's going to be less pull forward to drive it. Whereas in the US, I think it's extremely clear that the physical industries are goods in motion. By definition, goods in motion need sensors that can transmit in motion, which means wireless, and in essence means 5G. And unless we get that, we're not going to see the sort of innovation that drives job growth and wage growth.
So, real quick, and we'll go back, Jackie, and start with you, and then Michael and Neil. What, in your perspective, from the issues that you're focused on, what do you think are the one or two policy issues that are most time sensitive for Washington to focus on and resolve if we're going to allow 5G to realize the sorts of benefits, economic and otherwise, that we've been talking about thus far?
I think first is to continue progress on the long-term spectrum pipeline, because as we heard from the previous panel, 5G deployment nationally is, at least a 2 to 3 year or even longer proposition. So it does really require that long-term pipeline. And then I think, kind of thinking back to my day job of working with agencies like FAA or FDA, I think there is a real need for understanding in some of these sector-specific agencies that are grappling with, in many cases, new entrants from our wireless sector, to understand how kind of our bread and butter issues of spectrum and infrastructure, but also security and privacy impact their businesses. For example, we see in the auto sector and with the Department of Transportation and NHTSA, there's a lot of interest and concern about how automated vehicles and that whole ecosystem can be secured. We're seeing the FDA is a little bit farther behind some agencies, but just recently announced some guidance on cybersecurity of medical devices.
Thanks. 2 points. One is when people think about 5G, a lot of state and local governments, they think about 5G phones and does 5G give you better streaming video to your phone? Okay, and so when they think about regulations, about access points or so forth, they're thinking in terms of consumers, when really they should be thinking in terms of the benefits for their industries in their area. This is an enabling technology for industrial growth. And related to that, they should think about how this can boost U.S. competitiveness on the trade front, on the productivity front, on the innovation front. So when we frame it in that, it becomes less of a technical issue and more of a national imperative.
I have 2 points too. The first one, just building on my previous remarks. I do think the privacy data security fight is really important. It's really challenging. I would encourage the U.S. approach to be expanded slightly, but not to take hold on the GDPR approach. I do think that case-by-case enforcement that focuses on outcomes is much better and much more able to keep up with such a dynamic technology than one where you're trying to design the world ahead of time, trying to say how people should collect and when. If we focus on are you harming consumers or not, that is a much more tractable problem. And actually I thought Bill Lair's point earlier that part of this, the great thing about these networks is you build them and then you figure out the uses for them. And imagine being a regulator trying to design a regulatory system ahead of time when that's the case. It's very challenging. On the second point, I would just say lowering barriers to getting on the network. We hear this a lot in the adoption arguments around, the U.S. does not have enough people online. It has a lower percentage of people who have broadband connections than other countries. And I do think that's really important. These are networks, and so they have network effects, so the more people that are on them, it's better for all of us. But we talk about it often from the consumer side, but it's also really important from the service provider side. The more companies, the more devices, the more connections we have from the service provider side, that's better for all of us too. And we often think about how to lower the barriers for consumers, but the trend lately has been to raise the barriers to get in online for companies. And GDPR is an example of that. And I think if we're trying to get manufacturers who are in Ohio or upstate New York online using these things, we're going to want to make the regulatory barriers as reasonable as possible.
We can pause here to ask if there are any questions from our audience members. Anyone, including the first panel? Yes.
Hi, Derek Johnson from Samsung. You make a great point, which is, in the regulatory environment, I think there's a lot of focus on it at a national level, right, at a federal level, if you will. How about, can you guys speak to the local municipalities? Because I think one of the challenges we had is this kind of awareness of, when you talk about kind of a manufacturing facility in upstate New York, but folks there may, look at wireless infrastructure and say, no, not in my backyard, and therefore now you've hindered that plant from being able to get access to fiber and things of that nature.
Right, I think that's a really important point, because remember, when you're building manufacturing, you're building plants in places that are less dense by definition. Okay, so the economic hurdle is bigger, and you have to make the justification not simply by the number of people with phones in the area, but by the use by companies and by the potential use by companies. And making this argument to state and local officials requires an act of imagination, which is hard at this point. Now, I think it's getting easier. I think people are starting to understand that, hey, innovation is not simply a way of getting rid of manufacturing jobs, but it's a way of creating. I will refer people to the paper that it just came out in August on the Internet of Goods that we put out, because it goes into depth in a lot of this. I think that we're going to get better at being able to tell this story on the state and local level. And then once they start to see that this is happening, it's going to be a domino effect. But the problem is that the areas that went first, that were maybe easier first to build 5G networks, will have an advantage.
I think there's also a benefit of viewing some of those local governments as 5G consumers, and that really can go a long way toward understanding that those technologies and the benefits that come from them require infrastructure, require an environment that's conducive to build out. An example I just thought of is in one of the communities just outside Houston that received a lot of federal aid post-Hurricane Harvey, is starting to work with our members to digitize their water monitoring system. They're in a floodplain. I think, unfortunately, they are expecting that they will be faced with those kinds of events in the future, and so they're seeing that getting more of that intelligence in what's otherwise a decades-old system requires that backbone.
Let me add one more thing. We do a lot of work in both Europe and Japan. The Japanese regulators are conflicted at this point. Okay, they keep, and it's true for the European regulators too. They keep writing reports as if they understand what's happening, and they keep behaving as if they don't. So at some point it will resolve itself one way or the other, but it's weird at this point when we talk to them.
And I'll just add to that, just building on Michael's story point, and how the importance of stories. It's bigger than 5G, but one of the big concerns, I mentioned that at CKI we pay a lot of attention to the cultural impacts of innovation. And at this point at least, it seems like we're constantly being told that you should be afraid of the future and what technology is going to bring. And I think the US at least has been quite good in the past of getting past those sorts of fears pretty quickly. But I do worry that if we have this false nostalgia for the past, a past that was on almost every dimension worse for everybody than the current time, I think that we will, on average, I think that if we lose that interest in optimistically taking some risks and trying out new things, that we will fall behind places like China where competition is fierce and they are sort of more the frontier in some ways in the Wild West sense than the US, and I worry about that.
The only thing I'll add, and then we'll go right here, we have two questions, is to build on Jackie's point, which is to think of these localities as users of the technology. And it's not to suggest that others haven't tried that in the past, but to recognize, as Commissioner Carr was saying, a sense of humility, right? They have interacted with other technology sectors before, and not to throw maybe cable under the bus, but perhaps that interaction wasn't necessarily satisfying for them. So we have to go in knowing this is not the first time they're sitting with technology or technology companies and representatives, and it's an opportunity for folks such as Jackie's organization and others around the country to get in there, roll the sleeves up, and do a lot of interaction with these guys so it's not quite so scary, and we explain clearly and hopefully convincingly why what we're proposing is as good for them as it would be for their citizens. Question?
I had two questions. The first was, I was struck when Michael Mandel described privacy policy in China's in the Wild West, because I was like, really? I thought it was more like the Panopticon in 1984. So I'd like you to comment on that. And then anybody, we didn't, the first session I think talked about as if most of the future of 5G is going to be carrier-centric, and I think that probably is true. But 5G also opens up all these possibilities for municipal networks, community networks, neutral host businesses, or end-user deployed types of networking. I'm interested in what policy reforms should be designed to allow this to happen. How important will those be?
So in Europe, of course, the goal is for users to have control over their own data. In China, just as you say with the Panopticon, people don't have control over their own data. Okay? They have zero control, basically, and they're not moving in that direction. And for the companies at this point are interacting with the government, but the companies don't have the same, they certainly don't have the same rules that that European companies have, and they have a lot less rules than US companies have. So when you look, you sort of say, there's a lot of uses of data out there for things like feeding artificial intelligence, right, that would be much more difficult in Europe and perhaps much more difficult in the US. So that's the sense in which I'm in. And, you know, we also sort of run into, of course, this differing views about uses of data by the private sector versus uses of data by the government. And Europe is a little bit conflicted about that too. So that is a different perspective. But yeah, I mean, I think it's pretty much true that there's three models out there, and they're all competing to see which is going to be the most successful over the long term.
Yeah, I think I would just add in, yeah, to me the big distinction is between government use of data, government access, government control of data, and commercial uses. The feedback loops are much clearer in the commercial space. There's reasons why we have constitutional limits in the US, and those don't exist the same way in Europe or China in most cases. And so to me the solution wouldn't be to have the US government have more access to data so they could give it to companies. I think that would be a major problem. But to use an approach that focuses more on where are consumers being harmed, treating it less. In some ways, the property metaphor for data that Europe has gone whole hog on doesn't work very well. There's a lot of data that's jointly produced by my interactions with someone else. So this conversation is it my data? Is it your data? Those sorts of things, like a property metaphor doesn't work particularly well, and that's the kind of data, those types of interactions are the types of data that actually power a lot of these algorithms. And so I think the US, in taking an outcome-based approach, has struck the balance better, and we have a nice natural experiment here. So I guess we'll see.
Yes, so my question is about that if 5G, 4G require densification of the networks to get the capacity, and you need access to all these lampposts or buildings, and what kind of regulatory framework you need so that you don't have to negotiate with multiple municipalities to get into these building plans?
I think as Commissioner Carr discussed this morning, having some guideposts and reasonable expectations surrounding the deployment of small cells, which are, as you mentioned, on existing structures and can be built, very quickly and have a comparatively low, aesthetic and infrastructure impact, has been really important. But I think, those reforms, while we're thrilled to see them, don't remove the need for carriers and their municipal governments to work together. Because I think the scale of this in terms of the hundreds of thousands of small cell sites that U.S. carriers will need are going to really require a pretty high level of cooperation.
One thing I would add there is it also requires the companies, and not just the carriers, but the folks who are maybe subcontractors, et cetera, to be respectful, right? So we do have those municipalities out there, and they do have to be dealt with, perhaps individually, in some cases, perhaps collectively. But it's really important now that as we're going in to have best practices. So for example, in Baltimore, it didn't really help the industry writ large when it was not a carrier, it was a subcontractor, was putting up small cells without any permitting and using electric power cord from the lamp post to an indoor outlet of the corner at, an indoor outlet at a building that was at the corner. Not only was it unsafe for the person who was doing the installation, but obviously the city of Baltimore did not take kindly. That made it much more difficult for the carriers coming in behind the one who had hired that subcontractor to come in and have a good relationship. So it's really incumbent upon all folks in the stack of getting these networks built to really proceed with respect, humility, and best practices, I think.
I have a second question on the spectrum. So for the World Radio Conference 2019 and 2020, what kind of bands will the US be advocating?
That's, I think, 5G bands across, low, mid, and high band spectrum, and globally harmonized bands, because a number of our equipment providers like Nokia and other companies are building, components that need to be used globally, not just in the US, is going to be the focus of our strategy.
Well, that brings us to noon. One more question? today's conversation, as you all can tell, there is still much, much more to talk about, not the least of which is how does the capability for networks